Today we're going to talk about free energy. But before we do that, we're going to talk about spontaneous reactions and non-spontaneous reactions first. So what are spontaneous reactions? Spontaneous reactions are reactions that occur with being driven by some outside force. And what are non-spontaneous reactions? Non-spontaneous reactions are reactions that occur without being driven by some outside forces. So, what kind of outside forces are there? In free energy, we mainly talk about two. First one being enthalpy, and the other one being entropy. So, let's talk about enthalpy first. What is enthalpy? Enthalpy is the heat involved or absorbed in a reaction. And then, of course, there will be positive enthalpy and there will be negative enthalpy. For the reaction that has a positive enthalpy, we call them endothermic. For the reactions that have a negative enthalpy, we call them exothermic. Endothermic reaction absorbs heat from its surroundings, which decreases the temperature of it. Exothermic reaction releases heat to the surroundings, which increases the temperature of it. So how do we find the enthalpy of one function? We use Hess law to find it. And here is the equation of it. Enthalpy is a state function, which means no matter what the process is, if the beginning and the end are the same, then the value of enthalpy is the same. So what is Hess law? Hess law states that the enthalpy change of one reaction, which is delta H reaction on the left-hand side, is equal to the sum of all the enthalpies of products minus the sum of enthalpy of the reactants. So now let's talk about entropy. What is entropy? Entropy is a measure of the disorder or randomness of a system. And that directly goes to the second law of thermodynamics, which states any spontaneous process increases the disorder of the universe. So how do we calculate entropy? We use the process that is exactly the same as how we calculate enthalpy. So here is how we calculate entropy. The change of entropy of one system is equal to the sum of the entropy of the products minus the sum of the entropy of the reactants. Also, because of the function, entropy is also a state function, which means no matter what the process is, if the beginning and the end stays the same, then the value of entropy change is the same. Entropy is very hard to measure, but we can predict entropy just based on equations. There are two main ways to predict entropy change, whether the entropy increases or the entropy decreases. The first way of predicting entropy change is looking at the change of number of moles of one reaction. So here's a reaction. Carbon and oxygen react to produce carbon dioxide. 1 mole of carbon and 1 mole of oxygen on the reactant side. While on the product side, there's only 1 mole of carbon dioxide. The number of moles changed from 2 moles to 1 mole, which means the entropy of the reaction is decreasing. The second way of predicting entropy change is looking at the phase change. Here is a reaction. 2 moles of hydrogen and 1 mole of oxygen reacting to produce 2 moles of water, while hydrogen and oxygen are both in gas state. Water as a product is in liquid state. That means the entropy of this reaction has decreased as well. Josiah William Gibbs. Find out how to use enthalpy and entropy to predict whether a reaction is spontaneous reaction or non-spontaneous reaction. Gibbs free energy is the measure that we use to predict whether the reaction is spontaneous or not. How do we calculate Gibbs free energy then? Similar to Hess's law, we calculate the change of free energy in one reaction by using the sum of free energy in the products minus the sum of free energy of the reactants. Because the function is so similar to the Hess law function, it means Gibbs free energy is also a state function. Another way to calculate Gibbs free energy is by using the enthalpy and entropy and temperature of the reaction. This equation states that Gibbs free energy change can be calculated by using the enthalpy change of the equation minus the temperature times the entropy change of the equation. We can determine whether the reaction is spontaneous or not just by looking at the sign of the free energy. If the free energy is positive, then we say the reaction is non-spontaneous. If the free energy change is negative, then we say the reaction is spontaneous. When the free energy equals to 0, then we say the reaction is at equilibrium. However, whether or not the reaction is spontaneous, it has nothing to do with the speed of the reaction. A spontaneous reaction can be really slow, like rusting. When we use this equation, we need to take a very careful look at the unit of each measure. The changing enthalpy is usually given in kilojoules, while the unit of change in entropy is normally given in joules per Kelvin. And then the unit of free energy is always in joules. So while calculating, we need to convert units either to kilojoules or joules. When the enthalpy change is greater than the product of temperature times the change of entropy, then we say the reaction is enthalpy driven, meaning enthalpy is the main outside force that forces the reaction to happen. When the enthalpy change is smaller than the product of the temperature and the entropy change, then the reaction is entropy driven, meaning the reaction is mainly driven by entropy to completion.
주 달콤히 맴돌아 나 꿈인 줄 모르고 start 애매히고 있어 그냥 어지러운가 봐요 잠이 든 그댄 아무 말도 말아요
Thank you for listening, and special credit goes to Kira, Faith Warmhold.
Yeah, man.